Hi there. So I'm just going to give you a brief explanation about what parametric differentiation is. Um, I won't go into it in great detail. Once I explain it, hopefully it'll be relatively clear to you, and then you can carry on to the next few examples and then try the exercise that I've issued for you. So basically what we're talking about with parametric differentiation, if you've got a point just in the xy plane, now the x coordinate can change in a different manner to how the y coordinate changes. So there can be an equation associated with what happens to the x coordinate and a separate equation telling you how the y coordinate changes. So you can have a coordinate where it's not like over a period of time the x will double and the y will double, or they'll both be squared or something like that. You can have something different happening to the x coordinate compared to the y coordinate. So in this example here, it tells you as time changes, so t is time, that can be in seconds or whatever. So it's telling you that as time progresses, x is equal to the time squared, and y is just 2 times the time. So x is going to increase a lot more than y is, because squaring is going to be, it's a higher power there, so it's going to be a much larger answer as t changes compared to y. So the x and the y change in different ways. So if we've got t equal to 3 seconds, or 3 minutes, or whatever it happens to be in, however it doesn't say the units here. So if x is equal to 3 squared, gives you 9, and y is just 2 times 3, which is 6. That's just using these two equations here. So at the point when time is equal to 3, the new coordinate is going to be 9, 6. Now, the equations telling you how x and y change are known as parametric equations, and t is known as the parameter. So if you want to write down an expression for dy by dx, remember that's just a change in y compared to x. Now the change in y, that varies depending on what's happening with the time. So dy by dt is your change of y over time, and dx by dt is your change in x over time. So if we look at the two equations, your x equals t squared and y equals 2t, we can take the derivative of both of those things, and we can say dx by dt is 2t and dy by dt is 2. So therefore, using this bit in the orange box here, we can say that dy by dx is dy by dt, which is 2, over dx by dt, which is 2t. That's where your 2 over 2t comes from, and that simplifies to 1 over t. So we can get an expression for the derivative. Now, I've said in the notes to make sure you pay close attention to the Okamuti and the dynamic maths notes, because in these particular KHS notes, it's not very clear, this bit regarding the formula for the speed. So if you've got a formula for a parametric curve, where x is a function of t and y is also a function of t, your speed is just dx by dt all squared plus dy by dt all squared, and then square out the whole lot. You can see that's just essentially just Pythagoras that we've got there. So if you look at your other booklet that I've mentioned in the assignment, I'll give you some examples that you can practice on to help you to understand that a little bit better. Okay, hopefully that helps you today.